Hi, I'm Lauren Pisanik, an OpenSciEd teacher in New Jersey. Today I'm going to talk through some of the key moments of Lesson 11. So this is a lesson with a lot of big aha moments for students and some fun investigations and demonstrations. And we have some tips and tricks to share. So let's get started. First, let's think back to how we got here. So in Lesson 10, the students used and then revised a simulation to figure out what conditions cause strong storms. So we figured out that the strongest storms formed when there was high humidity and a really big difference between the low level and the high level temperatures. We realized at the end of the lesson, though, that we still needed to figure out why we don't have water droplets or ice crystals falling from the sky at all times. So that's what we'll explore in Lesson 11. Here's our lesson at a glance. Lesson 11 is a 2-day lesson with a series of short investigations and teacher demonstrations. There's a good amount of material prep in advance, and the teacher guide material prep section is key here. You'll create a poster, an air pressure poster in advance, and then just cover it up between classes. It's good to pay attention to the color directions in the teacher guide material prep section because students will use the same color on individual maps in a future lesson. 2 of the investigations are teacher demos, and there is a part 1 video that shows the setup and some of the troubleshooting. You'll want to test those yourself first before you do them with the students. And then the final setup video that's available shows you how to build a class homemade barometer, which you will use daily following this lesson. And that's something that you should make in advance. So it's good to budget about 45 minutes for the material prep for this lesson. Here's the overview for Lesson 11. It's broken into 2 days where most of those investigations and demos happen on day 1. So let's take a look at that day. So in the first chunk of the lesson, we brainstorm ideas about what might be holding stuff up in the clouds. So we investigate with tissue paper and ping pong balls to see if we can keep them up in the air, which is very fun. And this helps us to see that moving air exerts force on objects in its path. And then we also measure the objects using a scale, and we discuss the relationship between mass and weight before we measure and compare air forces in another investigation. And that helps us make sense of the idea that the more mass something has, the greater the force of gravity acting on it. And some students have this idea coming in, but now we have evidence to support it. Day 1 ends with students using this mathematical reasoning to predict how objects of different masses would move or not move in different lift force situations. In the next big section of the lesson, on day 2, we put what we figured out together into a class model. So now we're going to be able to show that an object will stay suspended in the air if the forces acting on it, right, the downward force of gravity and the upward force of air, if they're balanced. But if one of those forces is greater than the other, the object is going to move, either upward or downward. And then we'll brainstorm some causes for why updraft forces might be different and think about how to investigate them. And we'll also introduce a tool, a barometer, that will help us detect changes in the density of the air. So there's a lot happening in Lesson 11's 2 days. So here are those big ideas we figure out again. The more mass something has, the greater the force of gravity pulling down on it. Moving air pushes matter in its path. And air moving upward can keep an object suspended or floating in the air when that upward force of air is balanced with the downward force of gravity. But if the forces aren't balanced, the object will start moving upward or downward. And we'll also learn about that barometer, another tool we can use. So this new information about lift force leaves us wondering at the end of the lesson, what causes more lift force in some clouds compared to others? And that would set us up to go into Lesson 12. Let's look at a few key moments in Lesson 11. After a quick exploration at the start of day 1, Part 3 starts a series of teacher demonstrations and discussions. So you want to consider seating here. It's helpful to move the students into a circle or near around a table where you can show a demonstration. So in part 3, the students are going to investigate weight using a digital scale. So they're going to use the scale, in this case, to measure the force of gravity. So we talk about using ounces as the unit of measurement. The teacher guide here gives a clear description of the relationship between matter, mass, and weight, and it's helpful to actually directly read this as close to the way it's written as possible. So the distinction between mass and weight isn't a major focus here. The students will still get confused and mix them up, but it is going to help them lay the groundwork for future grades. So the more we continuously repeat it, the more helpful that is for the kids. In part 7, the students are going to apply what they've now observed and what they've figured out with a ping pong ball and a hairdryer to what's happening within a cloud. So this activity asks students to use mathematical thinking to predict patterns as they compare the weight of an object, so the force of gravity acting on it, to the upward updraft force of air. So this is a really key moment to assess whether students are understanding the role of opposing forces in the air. You can also differentiate how you manage this activity in your classroom. So my co-teacher and I, in our inclusion classroom, pulled small groups of students who needed more math support here and had them talk through the comparison of the forces. So that allowed them to have more scaffolded practice with this idea, while other students chose to do it individually. At the start of day 2, we'll develop some initial explanations and develop a consensus model. So this is updating a progress tracker, but this is not an independent progress tracker where the students are writing their ideas. This is a scientist circle discussion. We are going to generalize what we figured out to any object that's released in the air. So we'll work together to create a key and then show a representation of the forces versus motion of an object for 3 cases: when the forces are equal, when the updraft forces are stronger, and when the updraft forces are weaker. So I have my students draw this consensus model in their individual science notebooks while we're doing it together as a whole class, because this is a concept that's key and is going to continue to return when they make their final explanation. In part 9, this is towards the end of day 2, we'll consider how we can detect changes in the air. So we explore a digital scale and how it can detect updrafts because we'll use it near a fan, but we have to recognize a digital scale is limited because it can only measure so much. It depends on its sensitivity. So here's where we can introduce a barometer as a tool that can detect very, very small changes in the air. And this is a really great time to connect it back to the soap and bubble investigation the students conducted in lesson 5. Here, though, the balloon is going to rise or fall based on the density of the outside air. So that's an important distinction. So we'll record the air pressure in the room and then make predictions about when we would see increases or decreases. Would it be on cloudy days or sunny days? What are we thinking? And this is also where we can start a weather log to record measurements every day. It's a great connection to our local weather as well. Okay, let's check out some materials, tips, and tricks. So part 3, we didn't actually talk about yet. It's at the start of day 1, and it's a quick activity. It is a favorite of the students. It's hilarious. The students are going to try to use a straw to keep a piece of tissue paper aloft. So you want to think about ways you can reduce material use here, and also use a timer to keep the exploration piece short. We just need 2 minutes. You could also do this as a whole group and just have a few student volunteers, but this is a really fun one for kids, so keep that in mind when you make your decision. My co-teacher and I actually made a quick video of this activity too to show absent students and then save for later. So that was really helpful to have for future years. Okay, we'll talk about these 2 investigations together because they're both addressed in the investigation part 1 setup video. So it's a short video, teacher prep video that helps a lot with what to do, why we're doing it, and troubleshooting. So it's important to know that kids love this ping pong demo, and it's really helpful to have them have multiple students repeatedly talk through the forces that are acting on the ping pong as they observe it. If you have trouble getting the ping pong to be suspended, we want it about a good 6 inches above the hairdryer. The teacher prep video shows you how you can use the top of a soda bottle to act like a funnel. That will help that. The final material you'll need to plan in advance is the homemade barometer. So again, there is an investigation setup video for this and has clear instructions about how to build the barometer and how to set it up for measurement. It's very helpful as you're creating your own, and it doesn't take too long to make as long as you have those materials. You only need one for all of your classes, but you are going to use it every day after this. There are quite a few new words that we encounter in this lesson. So first, we're bringing back that term mass. So we'll think back to what we know about it. And then we have a few terms, air pressure, barometer, and gravity, that for now we're going to consider words we encounter. We're going to add 2 terms to our word wall, though, as earned words. And those are higher and lower pressure air, and also lift force. We also have 2 new posters created in this lesson. So the air pressure poster that we create in advance and then reveal to students when we're talking about how a barometer works. And then that forces diagram consensus model that we create together. Both posters are really helpful in future lessons. So you either want to take a photo of them or save the posters to display. Wow, there is quite a lot going on in lesson 11. So I hope this video helps you to better understand some of those key moments and think through how they might go in your classroom. Lesson 11 is going to leave the students ready to investigate what causes more lift in one cloud versus another. So we'll test out some of those ideas during lesson 12. More investigations are coming. I hope to see you in the next video.